Hello, everyone, and welcome to Pure Malt TV, the Instant Innovation Series. In today's episode, we're going to be focusing on alcohol-free beer. With an estimated 1 in 15 beers sold now considered to be alcohol-free, and 32% of new product launches in the brewing category in 2019 coming from alcohol-free beer, it is one of the fastest growing trends in the beverage industry. With the market projected to be worth 25 billion by 2024 and 60 million hectolitres brewed and sold last year, brewers are constantly looking for solutions to create highly drinkable and sessionable alcohol-free beers. In today's webinar, we're going to introduce to you various techniques accessible to brewers to produce alcohol-free beers. And then by way of a virtual tasting, we're going to showcase our latest solutions here at Pure Malt for creating alcohol-free. I'd like to now introduce you to my colleague, Ruslan Hoffman, who's our sales manager for Europe and Russia. Ruslan will be presenting today from Berlin, and he will be taking you through the various production techniques available for producing alcohol-free beers.
Thank you, Ross, and hello from Berlin to everyone who joined the webinar today. It will be my pleasure to go through some of the existing production methods of alcohol-free beers together with you. Well, first of all, you should all be aware of the fact that there is a difference between the definition of alcohol-free and 0.0. Alcohol-free in most countries means analytically less than 0.5% by volume of alcohol, while 0.0 analytically means less than 0.05% by volume, so 10 times less ethanol, which is quite difficult to achieve. For the production of alcohol-free beers, different techniques have been developed in the past. Generally, the methods can be divided into physical separation techniques to remove the ethanol and techniques to avoid the production of alcohol during fermentation in the first place. Physical separation techniques again can be divided into vacuum distillation or evaporation and membrane filtration techniques. Limiting the production of alcohol may be achieved by arrested fermentation or the use of liquid malt concentrates with no fermentation necessary at all. Well, all techniques are industrial in use and do produce drinkable results with their relevance in the market. Thermal separation techniques utilize the different boiling points of mixed fluids. In our case, we want to separate ethanol from water. At atmospheric pressure, ethanol has its boiling point at 78 degrees Celsius and water at 100 degrees Celsius. By heating the water towards the beer towards the boiling point of ethanol, the alcohol concentration may be reduced. And to reduce the heat impact on the beer, lowering the absolute pressure to usually 60 to 200 millibars is common nowadays. Thanks to the created vacuum, temperatures of approximately 40 degrees centigrade are sufficient to evaporate the ethanol. The video that we are showing now, published by GEA, shall illustrate the basic principles of vacuum distillation. By creating a falling film or by using packed columns, the surface is increased, and given the necessary vacuum and temperature, the evaporation of ethanol takes place. The evaporated ethanol in its gaseous state is then collected in the upper part of the collection vessel, while the residual beer is collected in the lower part of the construction. By combining thin layer evaporation and subsequent packed columns with very high surface, the ethanol content of the final beer may be reduced to even less than 0.0%, making this method suitable for 0.0 beverages. Unfortunately, other volatile components like hop oils or esters may be evaporated together with the ethanol. By further separation processes, parts of the aroma fraction that is evaporated together with the ethanol may be collected and mixed back into the beer, resulting in reduced negative flavor impact if compared to the original beer. Due to its relatively high concentration, the ethanol fraction can be collected and used for disinfectant production, a practice that has proven very useful in the past month. The operation of a vacuum distillation plant for beer dealcoholization requires skilled operators, relatively high capital investment, and a blending station for carbon dioxide, deaerated water, or the aroma fraction that was recovered. If we look at membrane dealcoholization, it utilizes physical separation by size of the molecules and not by its boiling point. Most often, reverse osmosis is used to separate alcohol from the beer. We now want to show you a little video for reverse osmosis and its working principle.
Osmosis is a naturally occurring process in which a liquid, such as water, spontaneously passes through a membrane. The membrane or semi-permeable barrier allows some molecules, like water, through, but other molecules, like the majority of salts, are unable to easily pass through the membrane structure. The flow of liquid through such a membrane occurs naturally to try and even out the salt concentrations between the two solutions. That is, the liquid flows from the less concentrated solution, such as fresh water, to a more concentrated solution, such as seawater. When the direction of liquid flow is reversed, it's called reverse osmosis. By pressurizing the concentrated solution, in this case seawater, we are able to force water molecules in the reverse direction, from the salty seawater side through the membrane to the freshwater side.
In case of beer dealcoholization, we have fresh water or deaerated water on the one side and beer on the other side of the semi-permeable membrane, which is usually made from cellulose acetate or similar materials. By applying up to 40 bar pressure, we can force smaller molecules like water and ethanol to pass through from the beer into the deaerated water side. Bigger molecules like esters or higher alcohols and sugars are held back, and therefore the beer gets slightly concentrated and dealcoholized. Thanks to the effects of reverse osmosis, this is possible. But we still have to mix water and CO2 back into the original beer to get it back to its original strength. Typically, as I said, pressures of around 40 bar are necessary, and compared to evaporation, much lower temperature is necessary for a running process, usually less than room temperature, 10 to 15 degrees Celsius, which of course results in reduced negative flavor impacts on the resulting beer. As with evaporation, special units have to be installed, which lead to high investments, and also specialized operators are necessary here, as well as a constant supply of deaerated water, which is for a smaller brewer maybe not always feasible. In contrast to evaporation processes, the dealcoholization by membrane filtration is not suitable for concentrations lower than 0.05%, which makes it less suitable if you're looking for a 0.0 drink solution. Also, the ethanol content in the effluent stream is usually around 1.5 to 2%, which doesn't make it suitable for producing disinfectants, or less suitable as the effluent stream is, for example, with the vacuum distillation. If keeping your investment costs at a lower level is key for you, then special fermentation techniques may be applied. To avoid alcohol from being formed in the first place during fermentation, you may use interrupted fermentations or reduce the alcohol production during the fermentation. If in-house yeast strains for beer fermentation are used, two different techniques may be applied here. With arrested fermentations, the yeast is allowed to ferment up to 0.5% ABV and is then either heat treated or mechanically removed. Both results in a stopped ethanol formation. Another possibility is to use temperatures around 0 degrees Celsius. With these low temperatures, the metabolism of yeast strains for beer production is so limited that almost no ethanol is formed by fermentation. Still, the contact of vital yeast cells with wort does, however, result in formation of some aroma-active esters, as well as the reduction of carbonyls, which are usually responsible for typical wort aromas in the final beer. The selection of special yeast strains may be another alternative to limit ethanol formation during fermentation. A maltose negative yeast, as for example Saccharomyces ludwigii or Saccharomyces rosei, is not able to metabolize the main sugar of beer wort, the maltose. Only glucose, fructose, and sucrose are fermented, and those account for approximately 10% of the wort sugars. So as a result, the ethanol content is limited to less than 0.5% ABV. A lot of research is going on here to identify further alternative yeast strains, not only Saccharomyces, also non-Saccharomyces, but I would like to refer here to the known institutes in Germany, Belgium, or Finland who are doing a lot of really good work on this field. Generally, alternative fermentation techniques result in high amounts of residual sugars in the alcohol-free beer and therefore sweeter tastes in those beers. These beers also keep certain worthy off flavors, and adapting the brewhouse process may help to create low alcohol beers that were favored in tastings, for example, by using higher proportions of specialty malts, sufficient boiling times, or to reduce wort flavors, or for example, biological acidification in the brewhouse. But however, a full wort production process is necessary. They usually have their own recipes in the brewhouse, and during fermentation and maturation, these beers show very high risk of infection compared to regular beers, even with in-house yeast strains in the worst case, which could produce then more ethanol than you wanted to have in your beer. Malt extracts are made from the same raw materials as our wort, from malted barley. They are also traditionally brewed in a brew house, but as they are not necessarily subjected to alcoholic fermentation, creating a 0.0 beverage is possible from refined malt extracts when they are mixed with carbonated water and extracts of hops if you want to make an alcohol-free beer from them. By adding up to 10% of regular beer to a non-alcoholic beer, you create then a beer with maximum 0.5% ABV, which carries a lot of the original flavors of your main beer. And obviously the use of ZAB or zero alcohol base is not only limited to low alcohol beers as illustrated on the graph on the right side of your screen. On the negative side, a slightly worthy cereal flavor has to be noted. And although these extracts are brewed traditionally from 100% malted barley, they are not brewed at your brewery, what may have a negative effect on your brand's image. Advantages of using malt extract are the high degree of flexibility combined with an opportunity to produce a 0.0 drink without large investment costs for equipment. So, I hope my short summary of production techniques gave you a good overview of existing possibilities to create alcohol-free beers. And now I would like to hand back to Ross, who will guide you on through our webinar. Thank you very much.
Thanks very much, Ruslan, for your insightful overview of the different production techniques available to brewers in producing alcohol-free beers. What we would like to do at this stage of the webinar is to introduce to you our latest product, Pure Malt Zebra. And to do this, we've prepared a nice video introduction, which I will shortly share with you. Now, we are very quickly approaching the virtual webinar section of the virtual tasting section of our webinar, excuse me. But let me first share with you the introductory video to Pure Malt Zebra.
Individuality. It's what makes us stand out from the crowd. By taking what we do differently and letting it define us. Applying decades of learning, combining proven techniques, developing a product which tastes uncompromisingly unique. Pure Malt Zebra. Stand out from the crowd, blend in with the best.
So I hope you enjoyed that intro video, which will give you a flavor of the Pure Malt Zebra product that we will now head over for our virtual tasting to learn a bit more about. Now, unfortunately, we had hoped to send you over to a live stream of my colleague Simon in our new brewing facility here at Pure Malt. But with all the madness that's going on in the world at the moment, Simon has unfortunately been asked to self-isolate pending receiving the results of a COVID test. So fortunately, we had conducted some rehearsals of this webinar, and we do have a recording of the virtual tasting. And so it's with my apologies that we have to rely upon this, but we will now be sharing with you the recording from our rehearsals. So I'll now play this for you, and hopefully it's a decent experience.
Yes, thanks, Ross. You join us here in the new brew house, where we are really excited to be introducing our latest concept product in Pure Malt Zebra. Now, Zebra is in effect the result of over 20 years of learning since Pure Malt started developing ingredients for non-alcoholic beers. Some of you may be familiar with our ZAB products, ZAB standing for Zero Alcohol Base, and Zebra is the new arrival in this line of refined pale malt concentrates specifically designed as a base for 0.0 beer. The biggest challenge has always been achieving a really clean and crisp malt profile. We've all tasted those wort-y, green, cereal or cooked flavors, which can really detract from the drinking experience and make us feel that we are in some way making a compromise. With Zebra, we think we're pretty close to solving this issue. We have what we feel is a clean, crisp malt base, which provides a perfect foundation for you to flexibly formulate, design, and craft your own exceptional 0.0 products. I don't want to say too much more because I think, or at least I hope, that the product will speak for itself, but there are just a few things to mention before we crack open the bottles. Firstly, the bottles have been filled on our prototype bottling system, so we don't have perfect control over carbonation. Some may be slightly over-carbonated, some slightly under, some may be desperate to leak out the bottle at you. So I would urge you to be slightly cautious when opening the bottles. I'd like to stress that it is not a reflection of the product, but rather the bottling setup we have in the pilot plant. We would recommend that you enjoy these products chilled. So if your bottles aren't cold, by all means stay on the webinar now, but you will be able to rewatch the recording on demand when your bottles are down to temperature. These are our interpretation only, and by no means the golden recipe. The idea is that we want to convey the capabilities of the Zebra base, and of course you can assemble your own building blocks to create your own unique brand. There are no added sugar syrups in the prototypes. They are formulated using malt, water, and some great hop products from our friends at Totally Natural Solutions. We use these products to provide bitterness and aroma. The prototypes are vegan, and they contain between 60 and 70 calories per bottle. And very lastly, the formulation or recipe card should be available in the chat now. So you may want to have this open as we go through the tasting. So without further ado, we will crack open the first tasting here, which is a lager. So the Zebra lager here. You can see, hopefully, that we've gone for a premium lager feel with a nice golden color. The base component here with all the prototypes is, of course, the Zebra. And here we've also used a very small addition of CB400, which is a crystal malt concentrate, but it's solely to increase the color. It's not contributing much flavor at all. It's helping us lift the color to around 8.5 EBC whilst maintaining that clean pale malt profile. So on the aroma here, for us, this is a lot more beer-like than some of our previous efforts. And this is due to the clean Zebra base and of course, some of those lovely hop products from TNS. And as we taste now, with the lager, we're aiming for clean, crisp, and refreshing. We've got some balanced bitterness at around 25 IBUs. They're coming from the NISO product, which is a naturalized summarized hop extract. This incidentally provides the bitterness in all of the prototypes. The Zebra, providing plenty of body and mouthfeel. Again, it's about trying to simulate the experience of drinking a regular beer and bringing in all of the desirable properties that can be lost with the absence of alcohol. So in summary, clean, crisp, refreshing. Moving on now to the IPA. So the IPA here, the malt bill for this one is the same with the Zebra base and the CB465. This time we've increased the addition of the CB400, which again is a dark crystal malt concentrate, and we're now lifting the color to around 16 EBC, and it helps us achieve that lovely golden amber color typical of an IPA. So on the nose with this one, you're hopefully picking up some of the fruity and floral dry hop aroma that you would expect to get with an IPA. And on tasting, you may detect that we've very slightly increased the addition of Zebra. We're trying to reinforce that clean base malt. And with the addition of the CB400, we're bringing in complexity in the form of distinct dark crystal malt, some rich caramelized flavor, but with a dry finish. Again, I must stress this is our interpretation only, but we've increased the bitterness to 33 IBUs, and we've brought in some interesting aroma hop products to enhance that IPA character. And with this one, you're hopefully detecting plenty of body and mouthfeel brought about by the slightly higher additions in the malt bill. So that's the Zebra IPA. And moving on finally to the Zebra Stout. So a slightly more complex malt bill with the Stout. We've used the Zebra and the CB465. Again, that's bringing in the base crystal malts. We've also used 2 of our roast malt concentrates. The RB Smooth brings in some nice roasted chocolate notes, but it's the RB 1545, which at comparatively low addition rate and fairly low flavor contribution also gives us that typical dark stout color at around 90 EBC. On the nose with this one, you're hopefully getting some of those roast malt aromas, perhaps some vanilla and some coffee notes imparted by the innovative hop products and flavors. On tasting, I personally really like this one. You get some of those lovely chocolate and coffee notes, the smooth roasted malt profile. We've actually upped the addition of CB465, so you may pick out some dark caramelized crystal notes, which build that underlying complexity. And again, balanced bitterness at around 26 IBUs and good body and mouthfeel supported by Pure Malt Zebra. So finishing up there with the Stout. So that concludes the virtual tasting. I hope you've enjoyed the Zebra prototypes, but more importantly, I hope that they provoked some thought and potentially some questions. We would be delighted to get your feedback on the prototypes and of course, field any questions that you may have. If you don't have a direct contact within our team here, you can always get in touch with us via puremalt.com. There is a pop-up chat function and that you'll also find a Let's Talk form at the bottom of each product page on the website. And of course, we've got a dedicated sales team here, sales managers ready and willing to help and support with any upcoming or pending projects that you may have. So that concludes the tasting. Hope you enjoyed it, and back over to you, Ross, in the studio.
Thanks very much, Simon. I hope everybody enjoyed our virtual tasting and were able to get some of the sensory experience that Simon was explaining as he was tasting the products there live from our new brew house. So we're now rapidly closing in on the end of this first webinar that we've shared with you guys. But before we close today's session, what I would like to do is to introduce to you our next webinar, which will actually be taking place in 2 weeks' time on the 24th. So the next focus area for us is remaining within beer is on premium Pilsners. So we will be sharing with you different techniques to enhance bottom fermented beer styles, to give different malt profiles and different mouthfeel finishes, and how brewers can use novel ingredients in order to achieve those different types of characteristics. As with today's 0-0 session, our webinar on premium Pilsners will have a virtual tasting element. So we will be sending out samples of some of our ingredients for you guys to enjoy and to taste along with us. And I hope that by the time we go live with the Premium Pilsner webinar, that we will actually be able to host the live virtual tasting from our site here in Haddington. So that brings this session to a close. So thank you for signing up and for taking the time to come and join us today. I hope that we've been able to provide you some interesting insights into alcohol-free beer. And I hope you enjoyed the virtual tasting. Hopefully see you on one of our future webinars. Thanks, bye now.